Good day, Metric. Welcome back to my series where I'm still working this beautiful paper that was written on the 3rd of November 2023 by our Metric class of 2023. Of course, in this case, I'm going to be working functions, and that is question 4 and question 5 under one band, if not concurrently. So let's check question 4. What are they giving us? Question 4, I'm just trying to pen it down. Question 4, I'm going to underline it for you guys. And then they say that sketched below is the graph of f of x equaling to 2 raised to the x power minus 4, which is valid from negative 2 inclusive up until 4 exclusive. Okay, so I'm just going to pen it down as well. This is what we are given: 2 to the power x, take away 4, where x is defined only from negative 2 inclusive to 4, where 4 it is exclusive. Okay, so basically that is your domain. They are giving you guys the domain of the f, and then they ask you some plus or minus few questions around this. So let's check 4.1. Let's say write down the equation of the asymptote of f. So the equation of the asymptote, basically they are talking about this number that is here. We normally have it as in the form of q. Okay, and whenever you are dealing with exponential graph, you do not have the vertical asymptote, you only have what? The horizontal one. In this case, it's going to be y equaling to this value here, the way it is, and that is negative 4. That's how you answer the first question. And then number 2, which is 4.2, determine the coordinates of b. If they say determine, they wanted to work it out. But if they say write down the coordinate of b, you can somehow just write it down. But in this case, I'm going to say that at b, at b, y is 0 right there. At b, y is 0 at that particular point. We know that y is 0 there. Okay, so I'm going to substitute 0 from this equation and solve for x. Now we're going to have 2 to the power x, take away 4 is equals to 0. Therefore, we'll have 2 to the power x equaling to 4. Now, you see, to say 2 to the power 4 will be a waste of time now. Just say that x is equals to 2. And then you give them what they want, which is the coordinates of b. So b will be x being 2, but y value is 0. Okay, so that is the coordinate of b there. Now we go to the third equation, that is 4.3. Determine the equation of k, a straight line passing through the point a and b, just right there. Okay, in the form of k of x equaling to something. Okay, it's not really bad. You have the coordinate of b, which is 2 and 0. Now, you don't have, remember, to find the equation of the line, you need at least 2 points, okay, that the line passes through. So in this particular case, I'll say that at a, I'm going to look at a, so at a, x is 0 there. I'm going to find the y value at a, so y will be equals to 2 to the power 0 minus 4 is equals to 2. 2 to the power 0 is 1 minus 4. That is going to tie us down to a value of negative 3. So this tells you and me that the coordinates of a is 0 for x, but y value is negative 3. Now pay attention, they want the equation of the straight line, so you can just find the gradient of AB, which is going to be the change in y over the change in x between these 2 points. So that is negative 3 minus 0 over 0 minus 2, somewhere there. Okay, I'm just trying to, I'm moving from a to b. That is the gradient right there. And then you are going to get what? Negative 3 over negative 2. So therefore, the gradient of AB is equals to 3 over 2. This is only the gradient. You also want the equation. So the equation would be y equaling to mx plus c. So you can choose any point between b and a. I would like to choose the point b because it doesn't have negative. So I'll say at the point b, so the point b is 2 and 0. The gradient, I know it's 3 over 2. So the point y is 0. I'm going to have 0 is equals to the gradient, which is 3 over 2 times x. At this point, x is 2 plus c. Therefore, this will be 0 is equal to 3 plus c. And as a result, my c will be negative 3. Okay. So therefore, the equation of k, so k in the form of that is going to be 3 over 2x minus 3. Okay, that's how you really answer this type of questions. And then now you need to go to the next question. This was what was 4.3. So now we are going to 4.4. Calculate the vertical distance between k and f. So what we need to imagine here is the graph of k itself. So the graph of k passes through the point A and B. So I'm just trying to connect that to be a straight line. So you'll see that if that is your k, this is the k of x, the vertical distance we're talking about here will be this one. Okay, remember that here is 2, b at b is 2. So that means that the vertical distance is going to be that one, but they're telling you that x is 1. So this means that here x is 1. Okay, so they want this distance between that. So I'm going to say that the vertical distance is going to be equals to y top minus the y bottom. For the vertical distance, we subtract the y top against the y bottom, but for the horizontal distance is the x from the right, take away the x from the left of it. So now this is going to be equals to, what is the y at the top? Is the straight line, which is k of x. So this is k of x minus the y at the bottom, and that is the straight line, which is f of x. Now you substitute these graphs, which is 3 over 2x minus 3, take away f itself. So f is 2 to the power x minus 4. Hey, you know what is the value of x here, so you just need to substitute it into the equation. So 3 over 2 into x. X is 1. You are given just right here that x is 1. So I'm just going to put that bracket and say minus 3 minus 2 to the power 1, take away 4. So you can use a calculator here, and you'll see that 1.5 minus 3, it's like negative 3 over 2. This is negative 3 over 2 minus 2, so it's plus 2. So it's like minus 1.5 plus 2. That is going to give you guys a half, but don't forget to write units because this is the distance. So the distance here is just half. You can see it's very tiny, that distance. If you try to even imagine this distance, it's very tiny right here. It's a half distance. Okay, so let me put it, if that units, it's a half units. Now you look at the next question. So that is 4.5. Write down the equation of g if it is given that g is f plus 4. So now g of x is given by f of x plus 4. What is f? Now f, you are given that it is 2 to the power x minus 4. So this is 2 to the power x plus 4, minus 4. This is f. Now from f, I need to add 4d. So now you'll see that the equation of g is going to be this minus 4 and 4 are going to undo each other. So you're basically going to have 2 to the power x. Okay, that is 2 to the power x right there. That is the equation of G. And then now let's try and really do the other questions. That is 4.6. They say write down the domain of the G inverse. So what is the G inverse? The G inverse is the inverse of that graph. So now they want the domain of that inverse. So the domain of the inverse is basically the range of the exponential function, and the range of the inverse function is the domain of the exponential function. So basically now they want us to write the range of that graph. So the range of this is y bigger than 0. Okay, this graph is defined above 0, or above its asymptote. So now, because here we want the domain we're talking about the set of x values for which the graph is defined. It means this graph is going to be defined from x above 0. The range of this is y above 0, but because now the domain is the set of x values, hence I'm writing x bigger than 0, or you can say x is defined from 0 to positive infinity in the interval notation. Okay, and then 4.7, they say write down the equation of G in the form of that. I want you guys to pay attention. They're saying write down, not determine. If they say determine, we have to do the interchanging of x and y, or swiping x and y. In this case, they want you guys to write the inverse. Write down the inverse, of that. So they want it in the form of y equaling to that stuff. So this is going to be y equaling to the log. Remember that the inverse of the exponential graph is the logarithms, and the inverse of the exponential is the log itself. So it's just the vice versa of it. Now, if they say if this was your f and they say find the inverse, it means it was going to be the exponential. But because now is the reverse psychology situation, it means you're going to have the log of the base. The base here is 2 of the principal argument. In this case, it's x. So you're going to have y equaling to the log of the base 2 of x. Okay, then you get 2 marks for that. You get 2 marks for that, and you get 1 mark for this, and then you get mark for that stuff then, and the final answer here. Let me check 4.5. Oh, it's 1 mark. So it's basically your, is it 3 marks? Oh, the domain is 2 marks. And then here it's 1 mark. And then the vertical distance is the 3 marks 1. So you need to be able to get that equation. Okay, the correct substitution of 1 and the final answer then. That's how they are going to really give you marks, 2 marks there for the final answer. And then here, 4.3, the equation of that, it's how many marks? It's 3 marks as well. So you need to be able to get at least the coordinate of A and the gradient and the equation, So you get 3 marks there. And then the first equation was 1 mark there. And then number 2, the coordinate of B is just going to be the answer, and this equation where you equate that to 0. And then you solve that. It's going to give you guys 2 marks for that. That is the exponential and its inverse. Now, question 5. Let's look at it. I had a lot of students really calling me and crying about this question. I don't think it was really bad. It really attracted my attention, and then I had to look at it extensively, and my colleagues as well. I'm like, no, it wasn't really bad. It was a straightforward question. Let's check together. So this is question 5. So with regards to question 5, what are we given? The graph of f is given by a half minus half x minus 1 raised to the power 2 plus 8, and the g is given by d over x. So now they are giving you guys f, and that is negative 1 over 2 into x minus 1 to the power 2 plus 8, and g of x is equals to d over x, like that. That's what you guys are given, and you're given the intercept of f. Everything is given except the turning point at b there, but the intercept at least is given, and the y-intercept is not given, it's at c. So at c is the y-intercept, and at b is the turning point of this particular graph of interest. So I'm just gonna try and pen it down. Okay, 5.1, they say to you, write down the coordinates of the turning point of f, which is at b in this case. So the turning point of f will be the axis of symmetry and its maximum value there at 8. Okay, so this means that I'm going to have the coordinate of the turning point, which is TP. It's going to be, the turning point is B in this case. So that is B. So B there, it is what, that is going to be 1 and 8. You solve for x here, you take this part and equate it to 0, and then you solve for x. We call that axis of symmetry. You equate it to 0, but because they are saying write down, so we must just give them what they want, which is B equaling to 1 and 8. Now, 5.2, they say calculate. You see how they phrase the question, calculate the coordinates of C. So now, if you guys observe this from the bird's eye view, you will see that at C, x is 0. So what they mean is, in that graph of f, because that's where f passes through at C, wherever there is x, I'm going to put a 0, a young 0 in fact, and solve for y. So this should be, you shouldn't really take the laxity of your time doing these things. Just use calculator and you do it nicely. You'll get a 15 over 2. Okay, so they will say calculate the coordinate of C. Therefore, C is when x is 0 and 15 over 2. That is the coordinate of C. Okay. Now, let's move 5.3. 5.3, calculate the value of D. So the value of D belongs to the other graph. So it belongs to the graph of G. So that is y equaling to D over x. So, but D passes through the point B. Passes through what? The point B. So I'm going to say that at point B, that is 1 and 8. And substitute that into the equation of G and solve for D. Now, y is 8 at that point. D is what you are looking for. And then you have 1. So therefore, D is equals to 8. Like I keep saying, this paper was very easy. Look at this. It doesn't even take a half a second. So 5.4, they say determine the range of G. Okay. So that means that this graph now, the graph of G is equals to D, which is 8 over x. So they want the range of this. Normally, the range of this is affected by the value of Q if the graph is taken upwards or downwards. But in this case, it's just a grade 10 hyperbolic graph, where it is, not defined at 0, also x not defined at 0. So basically here, they are asking you to say, look, the range is the range, right? The range of this will be, remember, the range itself is the possible y values for which the graph is defined. So this graph here is defined everywhere on the real y-axis, okay? This graph is defined everywhere on the real y-axis except at a particular point, and that point is called the horizontal asymptote. In this case, that is the value of Q and is not here. So you must tell us that where y cannot be equals to the horizontal asymptote of this particular graph. Okay, and then the other way, if you guys love interval notation, you will say that it's y element of real numbers from negative infinity to 0, union, that means, or from 0 to positive infinity, like that. We are basically excluding 0 in that particular domain, but we allow anything from negative infinity. But when we get to 0, that's where the graph won't touch that. We call that the horizontal asymptote. So you can choose one of the two, but I love the first one. Okay, by giving you how many marks? It's 1 mark. Okay, I love that one. So now 5.5. So 5.5, they say, for which values of x will the multiplication of the two graphs be negative? So now I want you guys to be very careful. They want the values of x for which the multiplication of f and the g would give you guys something like negative, even 0 itself. So what I want you guys to really observe is that the best way to answer this type of question is that there is no way where you multiply like positive and positive and you get negative. And conversely, there is no way where you can multiply negative and negative and you get what? You get a negative. You get a positive if you multiply negative and negative. So it means here they are looking at a situation where f is positive, but g is negative. So when you multiply these two, signs, they give you guys less than or equals to 0. Okay. So now, conversely, if you multiply f being negative, but g now is positive, you are going to get a less than 0 as well. Okay. So now, what it means is we are going to first consider the first option where f is positive and g is negative. So positive in graph simply means above the x-axis. So let us look at f. This is f now. It is above the x-axis. That means the graph is positive. Okay. So I'm going to look at g where it's negative. Okay. So this graph below the x-axis is negative. Okay. So this graph here is negative. I'm just going to put a negative there. So if you guys check, when you multiply these two graphs, when x is -3, when you multiply them, they are going to give you guys forever less than 0. But now your problem now is that on this situation, when you take a 0, this graph won't be defined for the value of x. Remember, this graph is not defined at x being 0. So it means you're going to look at everything in between this region, which is -3 and and 0. But 0 is defined for both of them. So if you take -3, put it here, and also here, you'll get something. Okay. So, and if you take -3 inclusive, you'll even get a 0. That's why they are saying even the 0 is inclusive. Okay. So now the answer to that question will be that x should be bigger than or equals to -3, but it should be less than the value of 0. But 0, we can't include that because it's the vertical asymptote of the hyperbolic graph. Okay, so this is the case where f is positive and then now g is negative. Now I'm going to look at where g is negative. So g is negative where, observe it, it's negative in that region below the x-axis and also here. But now if you look at this region here, if you look at that region here, they are both negative. But here, let us look at g in that order. Just gonna look at g in this order. So this graph here is positive. Let me put positive, and then here is negative. Okay, so here is negative. So if you look at this stuff here, g is positive and then f is negative, which is this one. So that means that That means that I'm going to look at from 5 going this side. That's the only part where I'm going to get the multiplication of less than 0. But 5 is inclusive because it's defined on both graphs. So I'm going to say that or x is bigger than or equals to 5. It's defined there. Okay, that's how you guys will do that particular paper. It wasn't really that bad. 5.6. 5.6. What are they saying here? They are saying calculate the value of k, or values. In fact, calculate the values of k so that h, look at h now, h is equals to negative 2x plus k will not intersect the graph of g. So what is g? So g is basically 8 over x. We found that d for x. So they say find the values of k for which this graph will not intersect. So basically they are testing you about your grade 11 classes on algebra, where you are dealing with the complex roots, the imaginary roots, your non-real roots. Okay, so if the discriminant between two polynomials is negative, it demystifies that they will not intersect. So the only way to answer this question is to answer it in a reverse psychology problem, because they are saying will not intersect. So think about it in this way, like when they intersect themselves, that is g will equals to h. Now, if you are to look at their x values, they are going to be disconnected. So when they are disconnected, that's when we say they will never intersect. Okay, they will never cross each other, basically, in that sense. So now, that's the best way to answer that. But you have to look at it in terms of the roots as well, that the roots of this are going to be imaginary. That is to say that the discriminant, this is going to, remember that the roots of any quadratics really depends on the discriminant situation. So that means that the discriminant has to be disconnected. It has to be non-real, complex roots or imaginary roots. So I'm going to have g. So g is 8 over x equaling to h. h is negative 2x plus k there. Okay, you multiply it out by x just to clear the fraction up. You have 8 is equals to negative 2x squared and then a plus kx. So that is a quadratic, which is going to, if you were to bring everything this side, so you will have a 2x squared minus kx plus 8 is equals to 0. Okay, you will have that. Okay, yeah, that's what you guys are going to be having. So now I want us to find the discriminant of this. The roots of this are going to be disconnected, and that's when the discriminant is what is less than 0. Is the complex or imaginary roots. They will definitely not intersect, and you're going to have a b squared minus 4ac being less than 0. Therefore, what is b? B from the quadratic equation we know is the minus k there, and then you need to square that, and then a minus 4a is 2 times c is 8. This has to be less than 0. Therefore, you guys have k squared minus, this is going to be minus 8 times 8 is 64 less than 0. You can think about it in terms of the inequality situation, where you have to factorize this and get your critical values. You get k 8 minus, and then a plus d. So therefore the critical values of this is going to be k equaling to a plus or minus of 8, right? That's what you guys are going to have there. But I want us to really interpret this situation correctly. So far we have this one as the critical values. So if you want to imagine this particular equation here, which is going to be the polynomial, it means that In fact, you have to look at this one, okay, because that's the roots that we are looking for k. It means you're going to have -8 and 8 here. But the point of interest here, beautiful people, is less than 0. Less than 0 means below what? The x-axis, which in this case has to be in this particular part. So this value of k has to be here. Have to be what? Have to be here. Okay, so that means now our conclusion should be that k should range in between, but of course exclusive because the roots are imaginary. So you will have a -8 and 8 there. That's what you guys are going to have for that particular value of k. You know, if you have any question, you can always comment. I think I'm open for questions. Okay, so we can discuss it further. But that is how I'll really answer that particular question. And then now 5.7, what are they saying now? They are saying that h is a tangent to g at a particular point r. So this point now r is in the first quadrant, or rather is located in the first quadrant. Calculate t such that y equaling to f at x plus t intersect g at r. So there are many ways to answer this type of question. You can look at it in a calculus situation, you know, in a calculus situation. You can really look at it from that way, but I don't want to look at it from that particular way because it's just too much work. Let us analyze the graph itself here. So we have the graph of h. It's h and the g that really matters here. So h is equals to minus 2x plus k, okay? And g is equals to 8 over x. But now what they are telling us that point r is located in where? In the first quadrant. So it's in the first quadrant. Therefore, because k, we have two possible values of k there. So it means that k is going to be equals to 8 right there. Okay. Now, I will say that it means that h itself is going to have a negative gradient, but the y cut is going to be at 8 in the first quadrant. Think about it. You can't take the negative one because it's really going to cut in the negative y-axis. So g is 8 over x. I want us to look at it in this way. We have our, by the way, what I'm doing now is not important, okay? I'm just trying to analyze the problem itself now. You can use the calculus way of doing it, the derivative and the tangent and wara stuff, okay? So now you guys think about it in this way. This is the graph of f. F, by the way, is in the equation here. So I want to bring that attention there. And then the other graph, which is this one, allow me to have it maybe in a proper way, you know. I'm just going to have it that way. So now I have that. That is going to be my g, right? And then the other one is possibly my f. There is a tangent, you know, which is h. So the graph of h is a tangent to g at r. So allow me to have that there as a tangent. So that is going to be the point r. That is the point r. Okay? That is the point r there, and that is h. H has a negative gradient, hence I'm drawing it in that way. So this is the graph of h. It has a negative gradient. So now, beautiful people, I need to work it out. I need to work it out now. not really bad. You just need to have a maths new there. So let's find the point of interest, which is the point of R. If I can find that point R, I think I'll have made it. So the point R, that's where the graph of H and the G intersect, right? So let's do that. G is going to intersect with H of X. So what is G? G is still 8 over X equaling to H. H is negative 2 X plus 8. Therefore, you multiply everything by X, you get 8 is equaling to negative 2X plus 8X. You bring everything to the right hand side, you get 2x squared, and then minus 8x plus 8 is equal to 0. Therefore, you divide everything by 2 just to reduce it. It's x squared minus 4x plus 4 is equal to 0. And this boils down to a perfect square trinomial, you know, where you have x minus 2, and then that is equal to 0. Therefore, x is equal to, remember, this has to be a tangent, so you must really get the only one value of x. Don't get two of them. So that is 2. And you need to get the corresponding y value between the two functions. You can use g, you can use h. I love to use g because it's straightforward. So therefore, y will be g at 2, which is 8 over 2. That gives me 4. So this, as a result, tells you and me that the coordinate of R is 2 and 4. That R basically is the point of contact. The point of contact, okay? That is the point of contact. It's the point of tangency. Is the what? Is the point of tangency. So you're not done. You're not done. Now you found the coordinate of R. They say calculate calculate T such that this one here, y is equals to f of x plus t intersect g at R. So that means you have to use the point R here. So you will say that this is going to be at a point R. So the point R is 2 and 4. Therefore, this is 4 equaling to f of x, which is 2, plus t. As a result, you are going to get 4 there equaling to f is negative half x minus 1 plus 8, right? So I'm going to have a negative 1 over 2 into x. X is 2. Think about it. Minus 1, and then you square this plus 8 plus what we are looking for, which is t here. You get a 4 there, use calculator, it's going to be 1 times negative half plus 2. So it's going to be negative half plus 8, and that is going to give you 15 over 2 plus t. So therefore t is going to be equals to 4 minus 15 over 2. 4 minus 15 over 2, it gives me negative 7 over 2. It gives me negative 7 over 2. It gives me negative 7 over 2 for t. Or the other way to do this, is to have the coordinate of R. So R is at 2. I'm just trying to do some imagination here. R would be 2 and 4. So that means now, if you look at that distance here, let's really have this. So what is the point here? That is another way to do it. So it's to substitute 2 to get the point there. So let's call that point A. This will be 2, and you take 2, you substitute it into that particular graph of f to get the y value. I'm just trying to analyze it. If you try and do that, this is going to give you it's possibly 7.5 here. Okay, if you substitute that properly, so it's 15 divided by 2, so it's 7.5 years. That is a 7.5 here. So now they want the distance. I mean, in fact, not the distance, but the value of t. So that will be the case. So now they want the value of t such that y will be f of x plus t. So this will intersect at r. So what they are trying to say here is that, allow me to duplicate this graph. Oh, I took a wrong graph. I want this one. Duplicate it. And maybe have its own color. Maybe this one. And also, okay, cool. So now assume that this is what do you call that? This is f. So now I'm going to take f down so that it will intersect g at r. So this is how the graph will look like. Let me increase this. Okay, this is how the graph will intersect at r, at this particular point. So it will intersect there, which means the distance will be that minus 4. Okay, that distance, it's going to give you it has to be dropped down in order for that to intersect. So therefore this value here had to be dropped down, by how many units? By -7/2. Yeah, that's how you really analyze that question. And thank you very much, guys, for sticking and staying with me. And number pattern, I think I've done that together with your question 1. So we are left with finance and calculus, for which values of x will the tangent to that have a positive gradient. I will look into that together with question 8. Probability was a takeaway. Okay, they were giving you guys marks there. So guys, thank you very much for staying and sticking with me. See you next time.